All right. I'm going to shoot two videos here showing you how to make a lunar mosaic, a moon mosaic, a color moon mosaic. Now, in the first video, we're going to do a simplified case. And that's the case of your telescope. Its field of view covers the entire moon. So you got the whole moon in a single shot in red, a single shot in green, and a single shot in blue. And currently on the system, we have one telescope that can do this. It's the Hampton-Sydney College Observatory Telescope. So we're going to use data collected from there first. Now, our other telescopes, they have smaller fields of view. So if you want to image the whole moon, you have to tile, piece it together into a mosaic. That's more complicated. We'll do that in the next video. Okay. So let's take a look at the data. This is, again, from the Hampton-Sydney College Observatory Telescope. This is our blue image. This is our green image. And this is our red image. The red image we took in the H-alpha filter. The green image we took in the O3 filter. And the blue image we took in the U prime filter to cut down the amount of light that we're receiving so we don't saturate. Okay. Now, the first thing you want to do here, and with most analyses, with a couple exceptions, but for most analyses, we want to clean the image of cosmetic defects. Let me show you what these look like. Here's the same field twice, before and after. Just a bunch of stars, some nebular gas. But if we zoom in on the left, we can see there are also bad pixels. These little dots here, 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 here. You got some bad pixel clusters here. Bad pixels come in two varieties. You have hot pixels and cold pixels. Hot pixels are always bright, and cold pixels are always dark. No matter what you do, you can correct with biases, darks, flats. They're always there. You can't correct for them. And they contaminate your image. If you're looking at something faint, they're an eyesore, a distraction. And so we use this algorithm to get rid of them. When looking at something like the moon, it's so bright, you're not going to see these little defects, but they can mess up the alignment. So we still want to get rid of them. And sometimes you can have not just bad pixels, but entire bad columns. Here we have a column of cold pixels. They're all dark. Over here, we have a partial bad column. It's a mix of hot pixels and cold pixels. So again, these are things that we can get rid of. We run this algorithm and you see it identifies them through kind of a spatial pattern recognition and then removes them and replaces them with averages of the pixels around them. Okay. So let's run this. You go to the Cosmetic Correction tab. It's this one right here. Select all your images, which for us in this example, it's only 3, but often it could be a lot more. If you're doing a 5x5 mosaic, that's 25 times 3 filters, that's 75. You may have 75 images in here. Okay, and you really don't need to adjust anything else. Just hit the submit button. This doesn't take too long, just a moment. There, it's done. Okay. And again, since the moon is so bright, we didn't really see the defects, but they were there. Now they're gone. Okay. Next, we're going to align. And we're going to align this like it's a mosaic. Since we didn't have to tile, we don't really have to treat this as a mosaic, but we're going to align it as if it's a mosaic so you can start learning the skills and they'll transfer to the next video. So again, you select all your images, cancel out and select all. Make sure you're in mosaic mode. This turned on. For most of our astrophotography, we won't be doing mosaics, and this will be off. But this one's not a mosaic, but we're going to treat it like a mosaic. And so let's turn mosaicing on. These three you want to turn off: enable rotation, enable scale, enable skew. So it's going to try to align the red one to the green one to the blue one to the red one. It's going to check all combinations. If we turn those three off, all it's going to do is check shifts up, down, left, right to find the best place to put it. If we enable rotation, that gives it an extra degree of freedom. Scale can make one of the images bigger or smaller, and skew is like a stretching. And we don't need that much freedom. In fact, if you give it too much freedom, it can find incorrect solutions. So we're going to limit this to just shifts. So turn off rotation, scale, and skew. Now, the mode of alignment, there are all sorts of different options. For example, when aligning our planetary data, we'll use sources manual. When aligning fields with a lot of background stars, they will have a coordinate system on them. If you have a lot of background stars, you could use them to put a coordinate system, and we use the coordinate system. That's WCS, World Coordinate System. Here, we don't have background stars, so we can't use WCS. We're going to use feature-based alignment. We're going to use the features on the moon itself to do the alignment. And there are all sorts of algorithms for feature-based aligning. The common ones are listed here. We're going to use the AK's algorithm. It's a good compromise between the pros and the cons of all the different algorithms. Now, there are a number of parameters here. The only one we really need to concern ourselves with is the ratio threshold. When most people use the algorithm, they set it to 0.5. We've learned with lunar mosaics, 0.4 usually works better, but it's a bit of a guessing game. If you guess too high, you can get incorrect mosaics. If you guess too low, you can get partial mosaics where things don't fully align. We'll discuss this more in the next video. But 0.4 is our best guess, and so we'll start with that. And that does work in this case. Okay. Slide on down. I'm going to submit. Now the progress bar immediately pops up to 33%. Now it's going through the alignment checking. So we're up to 44%. And it could take a few minutes. So I think what I'm going to do is I'll pause the video and I'll resume it once it's done. All right. The alignment is done. And I've reloaded the images. Here's our aligned red image, our aligned green image, and our aligned blue image. Now, normally the next step is stacking. So you go down one tab to stacking. And what you do here is you take all of your red images, each of which has been aligned with the portion of the moon that you observe moved to the correct place, and you combine them. You stack them into a single image. Then you do it again for all your green images and for all your blue images, ending up with 3 stacks: a red stack, a green stack, and a blue stack. Now, in this case, we only have one red image, one green image, and one blue image. So there's nothing to stack. That's what makes this a special case. We didn't tile, and so there's nothing to stack. We didn't have to tile because each frame covers the entire moon. So more on this step in the next video. For something like this, we can skip it and move on to grouping and coloring. So we have our 3 images. I'm going to select them all. I'm going to group them. See, they've now been put in a group. I'll click on the group level, zoom to fit. And what we're looking at now is a combination of the 3 layers: the red layer, the green layer, and the blue layer. Now it looks very white, very bright, because we haven't colored the layers yet. So let's do that. Let's right-click on the red layer, the H alpha layer, color it red. There. Right click on the O3, color it green. Good. Right click on the U prime, color it blue. Okay, good. So this is a color image. There's still some adjustment that we can do to make it better, but we have color here. And keep in mind, the moon doesn't have very vibrant colors. They're very subtle. But you can kind of see that this region's bluer than surrounding regions due to, turns out, titanium mixed in with the rock, etc. Okay. Now, let's go to the Display Settings tab, the first tab up here. And what we're going to do on the Display Settings tab, you have options. I can look at the display settings for the red layer and adjust just that. I can look at the display settings for the green layer, adjust just that, or the display settings for the blue layer. It doesn't really matter which. Pick one, come over here to Color Composite Tools, and we're going to click on the first one, Link All Layers Percentile. That will link the other two layers to the layer that you selected. So now, if I adjust the brightness and contrast settings for the layer I selected, which was U prime, the blue layer, it doesn't matter which one you pick, just pick one. Now the others are linked to it. Like if I go to the red layer, it says the brightness and contrast settings are linked to U prime. So I can't adjust them here. I just go to this layer and I adjust it for this layer, and it will adjust it for all three layers in sync. That's nice. Okay. Now the first thing I want to do is I want to deal with these washed out regions. They're not saturated on the sensor. We didn't collect so much light that we flooded the sensor. There's stuff here. It's just how we're displaying the information on our screen. Just as a side note, when you're adjusting the display settings, you may want to turn the brightness of your monitor all the way up for this. Okay. So we can improve this by changing the stretch mode. That's down here. It's currently set to linear. We're going to try, well, you can see there are all sorts of different stretch modes. The first four, they'll let you see the faint stuff really well, but saturate or blow out the bright stuff, or you can look at the bright stuff really well, but you lose the faint stuff. This fifth one's special, called Midtone. It has an extra setting, so we're going to switch to Midtone. And you have to be patient. There are a lot of pixels in your browser right now after you make a mosaic or if you deal with a large field like this. So it may take a moment for your browser to update. So I put in Midtone. I'm going to hit the default preset to get some reasonable starter values in there. And you can see this region is no longer washed out. You have detail on the craters. But we also see the faint stuff. Now there are a couple settings here. And the key one is the midtone level, this one right here. If I increase it, things will get fainter. Let's increase it to like 99. I'll show you what that looks like. And, I can go 99.9 there. And the rest of the image is getting darker. We want to go the other way. Let's 90. Oh, that's too bright. Maybe 95. And so you can play with it until you have a level that you're happy with. Also, sometimes you have to increase the background, particularly after you do a mosaic, combining different tiles. The region around the moon may not be perfectly dark. Let me show you an example of that. See here, the region around the moon is not perfectly dark. By increasing the background level, you're picking what fraction of the pixels will be black. And by increasing it, you darken the outskirts of the image. You just don't want to increase it so much that you make the moon dark. I'll demonstrate here. If I increase this to 50%, probably not going to see any change. More than half the pixels in this image are already pretty dark. If I increase it to 90%, there, it did get darker. So we don't want that. I'll back it back down to 50%. You don't want the surface of the moon to get darker. Just the area around the moon, you want to make that nice and dark. Okay. That's about as good as we can do in Afterglow. So we're going to do two things. We're going to save it, save the group, and save it into your workspace. So under Files, you have a workspace, and you can save it there. Now, sometimes that fails. If it fails, it means you filled up your workspace, in which case you can go into your workspace and download some of the images you've done onto your computer, and then delete them, making space for you to save new things. After you've done all this work, you definitely want to save it in case you want to come back and change the display settings later on. The other thing we're going to do is download it. Now, there are two ways. This one here does just a screen capture of what's in the viewer. You don't want that. This one here downloads every single pixel. So I'm going to grab that. Here it is. So every single pixel's there. We have some slight color differences. Bluer due to titanium, browner due to iron. First thing you want to do is orient this the same as the moon in the sky. You may have to look up a picture of the moon, just Google a picture of the moon to get the proper orientation. I happen to know it very well, so it wasn't just a matter of rotation. I actually had to do a flip, but this matches the moon, at least as viewed from the northern hemisphere. Now, I'm using my picture viewer, but you could use whatever picture viewer you have on your computer. I'm also doing a little bit of cropping here. Frame it up the way that you like. Orient it correctly. Okay. And then we're going to do some other adjustments. The key other adjustment is the color saturation. There are subtle colors on the moon. This is how you can bring them out. Find color saturation, and you can decrease it or increase it. If I go all the way to the left, I end up with a monochromatic image. So if your image had some bad coloration, sometimes if you have flats, biases, and darks that are too old, you can get some unwanted colors. And then you can't really bring out the colors of the moon, but you don't need to throw the whole thing away. You can finish the analysis and just turn the colors off, and you still have a perfectly good monochromatic picture of the moon. This one didn't have those problems, so I can actually enhance these colors. So as I go this way, you see the blues are getting a deeper blue, and the browns are standing out a little bit more with respect to them. There are a lot of good colors on the other side of the moon, and I'll let you discover those yourself when you image a full moon. Now, word to the wise, you may not want to just slam it to 100%. That can create kind of an over-processed look. It differs for every data set. Sometimes it's perfectly fine to saturate the colors at 100%. Sometimes you want to be a little bit more subtle around it, maybe 50%. There are other things you can try. Some of these up here, you may have one called sharpening or clarity, and it can really make these craters here on the Terminator pop out. But again, you don't want to overdo it. Always zoom in and make sure it doesn't look over-processed. Lastly, you may want to adjust the brightness one last time. Something like that. That's a little too bright. I don't want to. See, if I go here, I start to blow out the bright regions again. So I'm going to go with something pretty close to what I had in Afterglow. Save it. There's a picture of the moon taken from Southern Virginia. All right, that's it for this video.